Hello, in this video we shall delve into the mathematics at play. Please do note that all angle measurements here will be made in degrees for simplicity's sake. Let's go through the model of the Earth. To start, let's first marshal all our powers of concentration and imagination to transform this oval-shaped object into a sphere. Let's then wrap two perpendicular axes around this sphere, i.e. the x and the y axis. These two axes will represent the equator and the prime meridian, the longitude and latitude respectively. We can represent our position as a 3D point marked as a letter P. Mind you that this very point is located on the surface of the Earth, of this object. Intersecting this very point is a vector of arbitrary length 1. Based on this vector, we can measure an angle in degrees from the center of axis and afterwards allocate the angles representing the rotation of the vector along the longitude and latitude, i.e. theta or phi, respectively. Alright then, knowing this, let's now coincide this knowledge with the GPS readings. As we all know already, the GPS calculates its position as a set of two angles catered to a 3D vector, which I previously described. We now need to represent the two angles as a 3D point on the sphere. We can do that using this formula, which you see right now on the screen. Mind you, it is necessary to subtract 90 degrees from the phi angle in order for the equation to work. Moving on, now that we have a decent representation of a 3D point on the sphere, let's now project this point in the confines of my compound. I figure that you, my dear viewer, have noticed from the previous videos that each of the points of the compound is also a 3D point. They are points C, D, E, and F. From the diagram, we clearly see that the borders marked CD and CF can be represented as axes X and inverted axis Y, respectively. For explanation's sake, I drew another set of axes parallel to the aforementioned ones, i.e. AB and AD. Concomitantly, I set up a point marked as a red crimson fat dot, whose position is represented by a horizontal and vertical degree of freedom, i.e. lines B and A. Once again, the formula is displayed. My written code, then having calculated the position of of ourselves, the object, recalculates it to fit in the screen. This should be all. Have a nice day, and I bid you all adieu.